So Helicobacter pylori is a bacterial strain that is probably one of the best known pathogens in the body. It tends to reside in the stomach, and it causes inflammation of the stomach, and over extended intervals it's also strongly associated with ulceration and gastric cancer. The statistics say that over half the world's population is infected with Helicobacter pylori. And before anyone gets freaked out about that, it turns out that it's not always a pathogen. It doesn't always lead to disease. It's really just a subset of people, and maybe a subset of the bugs themselves, that can cause problems. What we were really trying to understand was some of the earliest events as Helicobacter interacts with the stomach, and the need for the bug to find a niche to live in, the happy place, the right neighborhood where it can thrive. And so the question that we addressed was whether one of those niches had to do with the injury to the stomach, be it small or large, that could actually be an attractant to guide Helicobacter to a lovely little place to live within the stomach.
In other words, if the stomach's defences are already down in one particular place, this gives it really a chink in your armour so it can go in there.
Precisely right. We study mice that have been anesthetized, surgically prepared so that their stomach mucosa, the surface of the stomach where the food would normally sit, is actually directly adjacent to a microscope objective so you can stare right at it. And in that environment, we've been able to use laser light to cause microscopic damage. Just a few cells get hurt, and the hole that results from the death and departure of the cells is filled in over about 10 minutes. And so we added Helicobacter into that mix. We used fluorescently labeled bugs that basically glow in the dark so that we can see them separately and clearly, and said, where do the bugs go? And the answer was quite dramatic, that they, within 10 minutes, would flock to the site of damage, accumulate tenfold higher than anywhere else, really focusing in just on that injury site.
What would be the implication of this for the 50% of the world's population who have got Helicobacter pylori in their stomachs?
The implication is that if you have a small damage, it's going to be much more difficult to repair if you have Helicobacter. So even in the type of modest damage you might get if you've always heard about the damaging effects of aspirin. They make little small punctate lesions, little spotty lesions, rather than an entire damage to the stomach that will be more difficult to repair if you have Helicobacter present, because a Helicobacter will happily flock there and, through mechanisms we don't fully understand, rapidly get in the way of repairing even small little spots of damage. And so for people that are infected, it helps explain some of the very simple ways that Helicobacter can sustain injury to the stomach, lead to routes for that inflammation to happen. Your immune system will kick on and you'll get a more enhanced inflammatory response. Those are some of the earliest events known with Helicobacter.
Did you get any handle when you did these studies on what it is that's attracting the bugs there?
No, I wish we knew precisely what that was.
And so your theory or your hypothesis would be that the bugs flock to these areas because there's probably a bit of weakened defence, there's more nutrient for them there, but once they're there, then they're going to make a pain of themselves because they're going to slow down the healing process and potentially also make the lesions bigger so that you might end up with a full-blown ulcer in that site.
That's right. That's the hypothesis. Now, one of the things, there really are two questions that have come out of this, and it's embarrassing not to be able to answer either one. The first one is the one you suggested. We really don't know what that attractant is. We also have no idea why, when the bug is in place that quickly, how would it stop the repair?
So why do you think this is important as a discovery? Why should the average person, if half the population actually carry H. pylori, and we're all still here, all 7+ billion people of us on Earth, why is this important?
I think the impact is that you've now got an opportunity to understand some of these early events and get in the way. So I'm hoping this will give us some therapeutic targets where we can go after some early events causing these problems, even at a small damage site, before they get a chance to generate a larger erosion and an ulceration.